Hello, this is Moles Video 6, Limiting Reactants. It's AQA specification point 4324 and it's higher tier only. So limiting reactants goes hand in hand with a word excess. An excess is one that hopefully you've heard of in outside life rather than just chemistry, and it means too much. So if you have an excess of sugar, you're probably going to know about that later on. Limiting reactants would mean that you haven't got enough of something. Rather than jumping straight into chemistry, I'm going to use an example from that outside world and food, making a very, very simple and probably quite a sad sandwich here. The simplest possible sandwich: 2 bits of bread and 1 slice of ham reacts to form 1 sandwich. That's fine. Our balanced equation gives us the ratio 2 bread for every 1 ham. But you probably don't just buy 2 bits of bread. You go into the kitchen and there's 1 whole loaf of bread, and for some strange reason you decide to count how many slices are in there and discover there are 20 slices. You then look in the fridge and find there's 1 pack of ham. Apologies to any vegetarians out here, I went with something really simple. You look in and there are 5 slices of ham, and you suddenly feel compelled to start making as many sandwiches as you can. So, if we have a look, the ratio is 2 bread to every 1 ham. So if you've got 1 loaf of bread as 20 slices of bread, we're going to divide that by 2, and you would need 10 ham. And if we have a look, you only have 5 ham, so therefore the ham is the limiting reactant because there's less of it, and the bread is in excess. You can also work it back the other direction. For every 1 ham, you require 2 bread. There are 5 slices of ham, so this time we'll times by 2, and you would need 10 slices of bread, but you can see here you had 20, so it is clearly in excess. Right, what about doing it with some actual chemicals? Here is an already balanced equation. It is essential that you balance the equations before you try and do this. And then you look at the balanced equation and you work out the ratio of the 2 chemicals. So there's a big 2 in front of sodium, so it's 2. There's nothing written, so it means 1, so it's 2 to 1. For every 2 moles of sodium, you need 1 mole of Cl2. So here we go. 40 moles of sodium are given. How many moles of chlorine would you need? Well, just divide by 2. You would need 20 moles. Okay, slightly more complicated. 26 moles of sodium. How many moles of chlorine would you need? Well, look back up here. Number of sodiums, you divide by 2 every time. So 26 divided by 2, you would need 13 moles of chlorine. That's how we would use it. This is slightly closer to what an exam question might be. Zelda has 35 moles of sodium and 20 moles of chlorine, and you're asked which is the limiting reagent. Now if you just look at this and you see, well, 20 is smaller than 35, that's the limiting one. You go, oh hang on, what's this word? It's a sneaky word that basically means reactant, but the examiners quite like to do that. Remember what you've got to be able to show. Here it's just knowing that the limiting is the one that there's less of after you've considered the ratio. Don't worry about this word. So I've got 35 moles, well, Zelda has 35 moles of sodium. The ratio is 2 to 1, so divide by 2, we need 17.5 moles of Cl2. It turns out we have more than that. We have an excess, so therefore the limiting reagent is sodium. Again, you could double check it the other way. To go from chlorine to sodium, we would times it by 2 and discover that you need 40 moles of sodium. But you've only got 35 moles. It is what's limiting it. You will have chlorine left over. It's in excess. Okay, so here is what the exam questions will look like. They won't, well, you might be lucky and they might tell you the number of moles, but what's more likely is you have to do a few steps, and that's what really gets people. Here, you've been given the mass each time of the two reactants. You will have to turn that into a number of moles. So if you want, pause the video just now, try doing this all through yourself, and then check how I do. Okay, first step then. Yoshi has 10 grams of calcium, 10 grams of oxygen. Which one is the limiting reactant? Well, initially it looks like we've got the same amount of each. But if we have to turn it into moles first. So again, to get number of moles, sample mass divided by the mass of 1 mole. So we'll do calcium first. It's a sample mass of 10. Looking at the periodic table gives us 40. So we've got 0.25 moles of calcium, and that would be 1 mark. Doing the same thing for oxygen, sample mass is 10 again. O2, careful, not 16, 2 of them, it's 32. And that's 0.3125 moles of O2. So we now know how many moles there are for each of them. There is another step. Look at the balanced equation. What's the ratio? For every 2 calciums, there's only 1 of these. So if we have the calcium, divide by 2, and it tells us that we would need 0.125, excuse me, thinking on camera, moles of oxygen. We have far more of that. This is an excess. So the limiting reactant is the calcium, because we have far more oxygen than we need. We can again confirm this. What's the ratio when you go from oxygen to calcium? This time we have to multiply it by 2, and so therefore that means that we would need, if we want to react all of that oxygen, we would need 2 to 1 ratio, 0.625 moles of oxygen, and my apologies, of calcium. We need that many moles of calcium, and we don't have it. We would have this again as a limiting reactant. So it works whichever way you choose to do it. You don't have to do both of them. I'm just trying to show you that it works both ways. Okay, so here's a final example. Please read over it and then try doing it yourself and then confirm what you get. Okay, Luigi has 12 grams of water and 9 grams of lithium. Which one is in excess? First step, you have to balance the equation. If you did this without the balancing the equation, it will still work for you because it's 2 to 2 ratio, which is 1 to 1. So I was trying to be nice there. So first thing, after balancing the equation, we need to work out how many moles we've got. 12 grams of water divided by 18 is 0.67 moles of H2O, and 9 divided by 7 for lithium gives us 1.29 moles. The ratio is 2 to 2, which means 1 to 1. So therefore, if you've got 0.67 moles of water, you would need 0.67 moles of lithium. We've got more, so the lithium is in excess. Thank you.